Okay, so what we're going through is rational functions, and we went through an example before, a basic example worth 3 marks, in which the asymptotes were obtained by working out the x-intercepts of the function on the bottom. In this case, though, this one is a question which is using the addition of ordinates. Now, you don't necessarily have to. You'll see that in Year 12 methods this year, or if you've done it before. You can solve or answer a number of questions using addition of ordinates. You don't have to necessarily use them, but I think it's an important method which I'll sort of go through just briefly. Now, first of all, we've got the graphs of y equals 2 on x squared and minus x on 2. I've just drawn that on there just for the time being to help you identify what the shape of the graph is going to look like. So, you can see there that the green line, roughly, is the graph of minus x on 2. And I've also graphed 2 on x squared, which has an asymptote at both x equals 0 and y equals 0, and looks something like this. So first of all, what we need to do is we need to work out what the asymptotes are. And the asymptotes are when we know that this can't equal 0. We can't have x equaling 0. So there's an asymptote at x equals 0. Now, if that was the case, if given that can never equal 0, then we know that if that can never equal 0, then there's a straight line asymptote at y equals x minus 2. So there's an asymptote at y equals negative x over 2. So there are two asymptotes. That probably might give you a mark each for that. Some pretty easy marks there. A lot of students will get the x equals 0 part, but they will not get this one. Now, so we have an asymptote there. What we have to do now, though, is to get an idea of what this graph looks like, let's use the addition of ordinates. Now, let's think about it. Wherever the graph meets, obviously here, if we're looking at this area here, that's basically 0, isn't it? Now, I've got just above the x-axis and a line there, so it means that it's going to be hugging that line, y equals minus x on 2, but which side is it going to be hugging it on? It's going to be hugging it on the top, isn't it? So what we're saying is we're adding the ordinates. We're adding the graph of 2 on x squared and minus x on 2 to find the addition of ordinates. So I know that your graph wouldn't look like this, but it's just to show you guys could do it in grey lead if you wanted to in your exam, and then your final result. We know that there's an asymptote, so I'm going to perhaps erase that. That is going to be an asymptote of, let's just say, there you go. See, I did this to scale. Okay, that is the graph of y equals negative x on 2, and that's an asymptote. So the graph is clearly coming through there and hugging that asymptote. Then what do? We notice, though, what do we notice at this point where they meet? The y coordinate is double. That's right. So that's really important. So let's just say it's looking like that. And then as we get down the bottom, it's sort of approaching that. So as it turns out, we're going to have a graph which looks something like this. Okay? It's not perfect. Okay? But what you do notice is there's actually a turning point in there somewhere, which we're going to find. All right? So it's really important not to draw your graph straight away. But I'm trying to give you an idea of what it looks like. Similarly, over here, we've got a line. If I was to draw it from this direction, this is just to get what it's looking like. We know that we've got just above that line, or just above the x-axis, so it's going to basically hug the asymptote on this side, and as we get further and further up, what's it going to do? Isn't it going to just more or less, isn't it going to look something like this? Okay, can you see there that getting that shape really can, I think the best way of getting that shape is by adding ordinates. Okay? Now, of course, I would never advise you to draw a graph like that until you find the intercepts. Okay, so what we're going to do now is, all right, we've got a pretty good idea of what the graph's going to look like. It's going to look a lot better than that when you do your exam. But how do we go ahead and, so we've got our two asymptotes at x equals 0. Oops. Okay, there we go. We're back again. So we've got our two asymptotes at x equals 0, y equals negative x on 2. We've got a shape roughly. We can see there that there's not going to be a turning point over here. That's not a turning point or anything. It's not actually a turning point over there, or is it? Well, we'll find out. Okay? So, and we also know that it's going to cross the x-axis. Is it going to be a y-intercept? No, there's not. Okay, so let's go ahead and do the rest. How are we going to get the other 5 marks? Well, first of all, we can say that dy dx, let's do that, because it's asking for any turning points. Dy dx is what? Well, first of all, if I'm deriving that, that's x to the power of minus 2. Bring that out the front. So that's going to be minus 4 over x cubed. Is that right? Yes. Okay, and then that's minus a half. Okay, so I've found my derivative. Now I'm going to let that equal 0. I'm really struggling here with this pen. It's looking quite ugly. I will persist though. And I'll then solve for x. So therefore I've got like so. And I've got x cubed is equal to negative 8. So that means that therefore there's only one solution for that, isn't there? X equals minus 2. Now that means that there's a turning point. Is it a turning point or a point of inflection? It can't be a... I guess it is a turning point, isn't it? Yeah, it is a turning point. Well, we'll draw it on a CAS calculator to have a look. But, all right, let's... At a point of inflection, what's the double derivative equal? 0. All right, let's try it. We don't need to do this. So the double derivative, let's do the double derivative. Dy dx, or day squared y dx squared, so we're going to do that, that's going to be, let me just do that in my head, so that's going to be 12 on x to the power of 4. Okay. Yeah, no, it's not. I'll explain in a moment. Now, at the point x equals minus 2, at the point x equals minus 2, does the second derivative equal 0? No. So it's not a point of inflection, is it? It's a turning point, importantly to note. All right, when x equals minus 2, so therefore we've got a turning point here, and minus 2, what's the y coordinate for that? Someone tell me. What's the y coordinate of my turning point? That's minus a half, and it's 1, isn't it? what's that, minus 8, which is minus a half. What is it? 3 over 2, yes. All right, thanks. Hey guys. So I've got my turning point is minus 2, 3 over 2. And what's left over, we need to find turning points, intercepts, and state the coordinates of axis. So we need to find the x-intercept. What was the x-intercept? Come on, someone shout it out. Is it?
Cube root of 4.
Cube root of 4. Now you can leave that as so. Oh, jeez, I'm having some real troubles here.
What is it?
Cube root of 4, 0. Now, what is the cube root of 4? Roughly.
1.56.
Yeah, so... Is it 1.56, is it? Okay, that's great. Well, you're not going to know that, but remember that the cube root of 8 is 2, and the cube root of 1 is 1, so it's going to be somewhere between 1 and 2, isn't it? So this line here is going to look somewhere like, it's going to be more somewhere out here, isn't it? All right. Now, that's a pretty ugly looking drawing on my screen. I've been through the process. Let's have a look and see. All right. There we go. Now, first of all, only 19% of students got full marks for this, which less than, 19%. 48% of students couldn't even get a third mark. So that's over basically half the cohort couldn't get that third mark because of such poor sketching. Now, as I said, never sketch until you've got all your information. To get the shape, if you're confused about the shape, don't try and guess it. You don't have a calculator. So, as I said, it might pay to just draw an addition of ordinates, as I said. Now, importantly, that addition of ordinates would have given you the asymptote, okay? Because if you think about it, the drawing that I did, it would be hugging the line x minus 2, just looking at asymptotic behaviour. The turning point, minus 2 and 3 over 2. And over here, leave it as so. But what is important, though, is this. When you go and sketch that graph, they've given you a scale. They've given you a scale. So when I sketch this over here, it's important that because I didn't know what the x-intercept was, work out what the x-intercept is first. The cube root of 4 is between 1 and 2, and it's going to be closer to 1. Okay? So you would have to have that tracking along, and clearly that's not drawing that to scale. If that is... They would take a mark off. Yes, absolutely. Okay? So let's have a look at the question. The attempts of this question were quite varied. You can have a look at it here, but where did students lose the marks? Many students were able to find the equation of asymptotes, and many were able to find the turning point, but few were able to complete all of these successfully. Those who were able to fill all those requirements often did not show asymptotic behaviour. As I have said, if you've got something asymptoting and then it just shoots off again, then no, that's not asymptotic behaviour. You would lose a mark for that. Large number of students did not give coordinates for the intercept, so you have to give coordinates as stated. And just gave the x-coordinates. Sometimes there was no use of calculus to attempt to find the turning point. If there was no use of that, you couldn't get the method mark. The vertical asymptote was often labelled as y equals 0. Okay, so yes, there is an asymptote at x equals 0. Yada, yada, yada. What?
They said
No. It's x equals 0.
Yeah.
Sometimes they will, yeah. Okay, so there's a number of reasons, but not only if you got all of these correct, you needed to make sure little stupid things like it's around about 1.5 is the cube root of 4. So you wouldn't have got it perfect, But if you had it to the left of 1, for example, you would have been marked down. Okay, I'm going to stop there.